Good morning, everyone, and welcome back to our second session of online learning. As you know, we have been going over rainbows due to our St. Patrick's theme, and we are going to be performing a few really amazing science experiments today. But have you noticed that it's been raining? Let's come right on this way. How a rainbow forms. Well, when it rains and you have the sun hit the raindrops, it goes boing. It reflects light. And as it reflects light, it creates this beautiful list of colors. So essentially, it's a big reflection. The sun hits the raindrops and it refracts light. And that's what our eyes see. And there's a really fun song about rainbows that I'd like you to sing with me. Are you ready? And it goes to the tune, Twinkle, Twinkle, Little Star. First come red and orange, two, shiny yellow, green and blue. Purple ends the pretty days. First comes red and orange, two, shiny yellow, green and blue. Purple ends the pretty day. All righty, did you sing that? Fantastic. So let's look at today what our materials are going to be for our science experiment. If you can remember the scientific method here, the first thing that we start with is a question. So look at your materials here at the table. Can we look at our materials, camera guy? And these here are the materials. We have water, a plate. It can be a paper plate, a glass plate, or if you don't have paper or a white plate, you can use a pie dish that's clear. And M&Ms, and if you don't have M&Ms, you can use M&Ms or anything that has colors. Give it a try. That's what science is. It's all about exploring and discovering. So then we ask, what will happen when you mix water and Skittles or water and M&Ms? Let's look up at our sign here really quick, our poster on the scientific method. So we asked a question, and the next thing we do is we collect information and the materials, which we saw, and form a hypothesis. So I'm going to say, what do I think is going to happen? I hypothesize there'll be an explosion. Well, let's find out. Come on over and experiment with me. So each of you will take the Skittles for the first trial, and you'll place them in a circle. You have 2 sheets that will be emailed to you, and I'd like you to sort them before you do the experiment. How many red, orange, yellow, green, and purple did you have on your plate or in the design? Count them in total, color the one that you had, and do some other experimentation. What happens if you only have red and yellow and do this experiment? Then you can graph each number and compare. So this will be emailed to you along with the worksheet that goes to this experiment titled Skills STEM Science, which is science, technology, engineering, and math. So we have our materials, we've asked our question, and I've made a hypothesis. So now we're going to actually experiment. You're going to place the very first time the Skittles in a circle. You're going to take some water, and why don't we come up really close so we can see this? And I'm going to pour the water in. You want the S's of the Skittles to be up because we're going to notice something really cool happen. And it doesn't take very long. So if you come really close, and you can already see that the colors are starting to move forward towards the center of the dish. And it's happening, and it's happening. It's just like magic, and it's moving. But there are some really interesting things that I'm noticing here. And it's forming. We used cold water. Something else that you could use is very hot water. There is probably going to be a difference. It might happen immediately. You could try vinegar, or maybe even bubbly water or milk. Give it a shot. Try different things. So in science, we have our materials. And the thing that stays the same, which is the Skittles and the plate, those are called your constant variables. But the things that change, like the water, maybe you use vinegar or bubbly water, that is the manipulated variable, the thing that changes. So right now, take a look. We have this really cool tie-dye rainbow colors. Now, did you notice that there are colors coming straight forward and that they didn't mix? I'll tell you a secret. This is called water stratification. Each one of these Skittles has a different amount of density. Density is how heavy or how dense and compact something is. So something really heavy, like a metal block, is really, really dense. It doesn't have a lot of air in it. And then you have something with low density, maybe like a Lego, which has a lot of air. So the more dense something is, the heavier it is, and the less dense, like a pillow, which is perfect for pillow fights, you have low density. So these Skittles have different density. They have a different amount of oxygen. They have a different amount of salt, salinity, and also, as we mentioned, density. And this process with all of those different properties is called water stratification. So they don't mix in. It also has to do with the amount of molecules and them moving from one place to another. So the molecules started here and they started going towards the center. But if you look closely, look what's happening. The color is coming off the candle. But as you keep looking, you'll notice that the S stays there because they use different things, different chemicals to make the letter S. So on that note, what you're going to do is you're going to create, you already know what's happening, but you would indicate your hypothesis for a different experiment. Maybe you choose, let's try this. So here we go. I'm moving this over here. Here's our science experiment. What happens when you mix water and Skittles? I have changed something. I changed my design. That would be the manipulated variable. The constant variables that stay the same are the Skittles, the plate, and I'm still going to use water. So the water is the same. So let's find out, I have some more here, what happens when I pour this water onto this design. Here we go. Now, we've learned about water stratification and that the colors do not run into each other because of the different properties such as density, oxygen, the molecules moving from one place to another, and the saline, the salt. Look at that. So the colors are moving in their own directions, but they're still not mixing other than at the tips of the walls or the barriers. Do you see that? So try this at home, create different designs, and when you create your own design, or if you use a different liquid other than water, draw a picture of what you discover, and maybe your parents can help you write the conclusion. Once again, if you'd like to go and extend this lesson, there are some really neat things that you can do artistically, but look at that beautiful art that you can do. I wonder, can I use this color to paint a picture? I don't know. Please take a picture of your design before and after and post it on our Google album that will be emailed to you. All right, come over this way. Something to do at home for fun to extend fun rainbow lessons is make a rainbow using a pipe cleaner, which is nice, and this is great for fine motor skills, which we are really working hard to develop in both preschool and pre-kindergarten. And you will thread them, and at the very end, place in, oh, there's only two. Look at all hot marshmallow. Oops, don't eat it, unless you want to. And that's what you'll do to make your rainbow. Also, have fun making some creative snacks. I made a rainbow using some bell peppers. Maybe use strawberries, oranges, cheese, kiwi, or edamame. And I've used cheese, or you can use marshmallows. All Alrighty, I hope you have a rainbow sunny day. We'll be back tomorrow with another experiment and some more snacks. Thank you.